everyone. I'm just getting ready to get our next video recorded. We've been working our way through Chapter 1 on sequences and series, and in this video we're going to take a look at geometric sequences from Section 1.3. The objective of our lesson is to derive the formula for and work with a geometric sequence. Vocabulary you need to be looking for. Make sure you understand what is meant by the geometric sequence and something called the common ratio. So to start with, I've given you two sequences of numbers, and both of these are geometric. So the question is, what is the pattern that you see? If you were to take a look at this one closely, you realize that each number is becoming 5 times larger. So we're multiplying each one by 5. With the following one, we're taking each number and dividing it by -2. What these guys share in common is that they have a common ratio. And in a geometric sequence, the difference between the terms is something we call a common ratio. So a formula for this geometric sequence, it's actually a very simple process. If you look for the logic, each term will be multiplied by the ratio. And if you play around with that a little bit and look at what you have, we basically see that once we have a geometric sequence, we can use the following pattern. That whatever term you're looking for is equal to the first term times the ratio to the power of n minus 1, the common ratio. So working through a couple of examples then, they ask us to find the first 5 terms. Well, if our first term is 3 and the ratio is 4, then we would have 3, and then 12, and then 48, 192, 768. I am taking each one and multiplying it by 4. The next one, the first term is -1. So we take that one and multiply it by -2 over 3. Well, by 2 over 3 becomes -2 over 3. Times 2 over 3, 4 over 9, 8 over 27, and all of these, of course, are negative numbers. Determine the first 5 terms of the geometric sequence where you know that the first one is 2.3 and the fifth one is 186.3. So we can set this up as a simple equation, actually. We know that the fifth term is equal to the first term times the ratio 4 times. We put in our numbers for these terms that we know, divide by 2.3. We get that 81 is equal to the ratio to the power of 4, which is plus or minus 3. And if you consider that and name those first 5 terms, you can either have them all positive or every other one could be negative. Determine the first 5 terms where you know the third term and the sixth term. So again, we're going to use the very same kind of pattern. We know that the sixth term is equal to the third term times the ratio 3 times. Plug in your numbers, divide. You have r to the 3 equals 125, so your ratio is a 5. Now, you would have to go backwards a little bit. If this is your third term, you're going to have to divide by 5 and then divide by 5. So you've got those 3, and then multiply by 5 going forward. Derive a formula. So we would need to know the first term and the ratio. So let's see what we can find. We know the fifth term is this and the 10th term is this. 10th term is equal to the fifth term times the ratio 5 times. Put your numbers in, divide. You get a ratio to the power of 5 is 243. So that means your ratio is 3. Then if we're trying to figure out what the first term is, if we know the fifth term, we know that it's the first term times the ratio to the power of 4, which is 3 to the power of 4. And then if we do our math, we find that the first term is -2. Now, one thing I'm seeing that's not here, and it might be because I didn't screenshot it properly, but we're supposed to get a formula for this term. So the nth term, t to the n, would be equal to -2 times, in brackets, 3 to the power of n minus 1. And then lastly, determine the number of terms if you know the first term, the ratio, and what the actual last term is equal to. So we set it up. We put in that it's equal to this. We know our first term. We know our ratio. Then we do a little bit of math. So we multiply by 6, divide by 3. And then on both sides, we need to write things so they are a common base of 2. This is 2 to the power of 8. And if we have both of them at the common base, we know that this 8 has to equal n minus 1. And if 8 equals n minus 1, we know n is equal to 9. Okay, that's it. So please take a look at your homework, go through it carefully, and of course, bring any questions you have to class. All the best, everyone.